Section 110.26 applies to enclosures containing electrical equipment that generates or uses current or voltage that poses a hazard to qualified persons, that is, those who have the skills and knowledge related to the construction and operation of electrical equipment. In the case of a secondary overcurrent protection enclosure containing a single 175 amp circuit breaker, it's important to determine if the working space requirements of Section 110.26 are applicable. Circuit breakers are generally considered to be disconnecting devices. As such, they do not generate or use current or voltage that poses a hazard to qualified persons in the same way that other electrical equipment might. Therefore, the enclosure typically does not require the working space requirements specified in Section 110.26. However, there are additional considerations to keep in mind. Firstly, accessibility. The enclosure should be readily accessible for maintenance and operational purposes. This means ensuring that qualified personnel can easily reach the circuit breaker for inspection, testing, and any necessary repairs or replacements. Secondly, adequate ventilation. The enclosure should provide adequate ventilation to prevent the overheating of the circuit breaker. Overheating can cause the circuit breaker to malfunction, potentially leading to nuisance tripping or even failure. Proper ventilation helps to dissipate heat and maintain the circuit breaker's optimal operating temperature. Thirdly, labeling. The enclosure should be clearly labeled to indicate its purpose, the type of overcurrent device it contains, and its amperage rating. This labeling helps to identify the enclosure quickly and accurately, which is particularly important in emergency situations or during maintenance procedures. Now, let's elaborate on each of these considerations. Concerning accessibility, the specific requirements may vary depending on local codes and regulations, but the general principle is that the enclosure should not be obstructed by any permanent structures or equipment. Sufficient clearance should be provided around the enclosure to allow for safe and easy access by qualified personnel. Regarding ventilation, the amount of ventilation required will depend on the size and type of circuit breaker, as well as the ambient temperature of the surrounding environment. In some cases, natural ventilation may be sufficient, while in others forced ventilation may be necessary. It's important to consult with a qualified electrical engineer or contractor to determine the appropriate ventilation requirements for your specific installation. And finally, with respect to labeling, the labeling should be durable and easily readable, even in dimly lit conditions. The label should clearly indicate the purpose of the enclosure, such as secondary overcurrent protection, as well as the type of overcurrent device it contains, such as 175 amp circuit breaker. In addition to these considerations, it's also important to ensure that the enclosure is properly grounded and bonded to prevent electrical shock hazards. The grounding and bonding should be performed in accordance with the applicable electrical codes and standards. Furthermore, the enclosure should be constructed of materials that are suitable for the environment in which it is installed. For example, if the enclosure is located in a damp or corrosive environment, it should be made of corrosion-resistant materials. Now let's delve deeper into the NEC or National Electrical Code and its relevance to this topic. The NEC is a widely adopted standard for safe electrical installations. While Section 110.26 may not directly apply to the working space around a simple overcurrent protection enclosure, other sections of the NEC may still be relevant. For instance, Section 110.26 provides specific requirements for working space around electrical equipment operating at 600 volts, nominal, or less. This section specifies minimum clearances for depth, width, and height of the working space, depending on the voltage level and the presence of exposed live parts. While a single circuit breaker in an enclosure might not trigger the full application of Section 110.26, it's crucial to consider the overall electrical system and ensure that all applicable NEC requirements are met. Another relevant section of the NEC is Section 240, which covers overcurrent protection. This section provides requirements for the selection and installation of overcurrent protective devices, such as circuit breakers and fuses. It also addresses the coordination of overcurrent protection to ensure that the smallest overcurrent device opens first in the event of a fault, minimizing the extent of the outage. Furthermore, Section 408 of the NEC covers switchboards and panel boards. While a single circuit breaker enclosure is not a panel board in itself, it's often connected to a panel board or switchboard. Therefore, it's important to comply with the applicable requirements of Section 408 when installing and maintaining the overcurrent protection enclosure. In addition to the NEC, other standards and regulations may also apply to the installation and maintenance of electrical enclosures. These may include local building codes, industry standards, and manufacturers' recommendations. It's important to consult with a qualified electrical engineer or contractor to ensure that your installation complies with all applicable requirements. Now, let's consider some practical examples of how these principles apply in real-world scenarios. Imagine an industrial facility with a large number of electrical motors. Each motor is protected by a circuit breaker in an individual enclosure. While each individual enclosure may not require the full working space specified in Section 110.26, the overall layout of the motor control center must comply with the NEC requirements for working space and accessibility. This ensures that qualified personnel can safely access and maintain the motor control equipment. In another scenario, consider a commercial building with a distribution panel located in a confined space. The distribution panel is fed by a transformer with a secondary overcurrent protection enclosure located nearby. In this case, it's crucial to ensure that the working space around both the distribution panel and the overcurrent protection enclosure complies with the applicable NEC requirements. This may involve relocating equipment, modifying the enclosure, or providing additional ventilation to meet the code requirements. To summarize, while a secondary overcurrent protection enclosure containing a single circuit breaker may not always require the full working space requirements of Section 110.26 of the NEC, it's important to consider accessibility, ventilation, and labeling. Additionally, other sections of the NEC and other applicable standards and regulations may also apply. Consulting with a qualified electrical engineer or contractor is essential to ensure compliance with all applicable requirements and to maintain a safe and reliable electrical system. Remember that electrical safety is paramount, and it's always better to err on the side of caution when it comes to ensuring the safety of qualified personnel and the integrity of electrical equipment. By following these guidelines and seeking professional advice when needed, you can help to create a safe and efficient electrical environment. Furthermore, consider the potential for future expansion or modifications to the electrical system. If there is a possibility that additional equipment will be installed in the vicinity of the overcurrent protection enclosure in the future, it may be prudent to provide additional working space to accommodate these future needs. This can help to avoid costly and time-consuming rework later on. Also, keep in mind that the specific requirements for working space and accessibility may vary depending on the type of equipment being protected by the circuit breaker. For example, if the circuit breaker is protecting critical equipment such as life safety systems or emergency power systems, it may be subject to more stringent requirements. In these cases, it's essential to consult with the authority having jurisdiction, or OJ, to ensure that the installation complies with all applicable codes and regulations. In addition to the NEC, other standards and guidelines may provide additional information on best practices for electrical safety. For example, the National Fire Protection Association, or NFPA, publishes a variety of standards and guidelines related to electrical safety, including NFPA 70E, which covers electrical safety in the workplace. These resources can be valuable for understanding and implementing safe electrical work practices. It's also important to provide adequate training to qualified personnel who will be working on or around electrical equipment. This training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment, or PPE. By investing in training, you can help to ensure that your employees have the knowledge and skills necessary to work safely around electricity. Moreover, regular inspections and maintenance of electrical equipment are essential for maintaining a safe and reliable electrical system. These inspections should be performed by qualified personnel and should include a visual inspection of the equipment, as well as electrical testing to verify that the equipment is functioning properly. Any deficiencies identified during the inspection should be promptly corrected to prevent potential hazards. In addition to the technical aspects of electrical safety, it's also important to foster a culture of safety within your organization. This means creating an environment where employees feel comfortable reporting safety concerns and where safety is a top priority. By promoting a strong safety culture, you can help to prevent accidents and injuries and create a safer workplace for everyone. Ultimately, ensuring electrical safety is an ongoing process that requires a commitment from everyone in the organization. By following the guidelines outlined in this discussion and by staying informed about the latest codes, standards, and best practices, you can help to create a safe and reliable electrical environment for your employees, customers, and the public. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution when working with or around electrical equipment, and never hesitate to seek professional assistance when needed. Now, let's address some frequently asked questions related to this topic. One common question is whether the working space requirements of Section 110.26 apply to enclosures containing other types of electrical equipment, such as transformers or motor starters. The answer to this question depends on the specific characteristics of the equipment and the potential hazards it poses. In general, if the equipment generates or uses current or voltage that poses a hazard to qualified persons, the working space requirements of Section 110.26 will likely apply. Another common question is whether the working space requirements can be reduced or waived in certain circumstances. The NEC does allow for some exceptions to the working space requirements in certain situations, such as when the equipment is de-energized or when alternative safety measures are in place. However, these exceptions are typically subject to strict conditions and must be approved by the authority having jurisdiction. A further question often raised is whether the working space requirements apply to existing installations or only to new installations. The answer to this question depends on the specific code requirements and the extent of any modifications or renovations being performed. In general, if the existing installation does not comply with the current code requirements, it may be necessary to upgrade the installation to meet the current standards. Finally, a question frequently asked is how to determine the appropriate size and type of overcurrent protection for a particular application. The selection of overcurrent protection devices is a critical aspect of electrical safety and should be based on a thorough understanding of the electrical system and the equipment being protected. It's important to consult with a qualified electrical engineer or contractor to ensure that the overcurrent protection is properly sized and coordinated. In summary, addressing these frequently asked questions helps to clarify some of the common misconceptions and challenges related to working space requirements for electrical enclosures. By understanding these issues and seeking professional guidance when needed, you can help to ensure the safety and reliability of your electrical system. Furthermore, consider the impact of environmental factors on the electrical equipment and enclosures. For example, if the enclosure is located in an area that is subject to extreme temperatures, humidity, or corrosive substances, it may be necessary to provide additional protection to prevent damage or deterioration. This may involve using enclosures made of special materials, providing additional ventilation or heating, or applying protective coatings. Also, keep in mind that the working space requirements are not only intended to protect qualified personnel from electrical hazards, but also to provide adequate space for performing maintenance and repairs. If the working space is too cramped or obstructed, it can be difficult to access the equipment and perform necessary tasks safely and efficiently. Therefore, it's important to consider the long-term maintenance needs of the equipment when determining the appropriate working space requirements. In addition to the NEC, other standards and guidelines may provide additional information on best practices for electrical safety. For example, the Institute of Electrical and Electronics Engineers, or IEE, publishes a variety of standards and guidelines related to electrical power systems, including standards for grounding, bonding, and overcurrent protection. These resources can be valuable for understanding and implementing safe electrical work practices. It's also important to stay up to date on the latest changes to the electrical codes and standards. The NEC is typically updated every 3 years, and these updates may include significant changes to the working space requirements or other aspects of electrical safety. By staying informed about these changes, you can ensure that your installations comply with the latest requirements. Moreover, consider the potential for future technological advancements that may impact the design and installation of electrical enclosures. For example, the increasing use of smart grid technologies and renewable energy sources may require new types of enclosures or modifications to existing enclosures. By anticipating these changes, you can help to ensure that your electrical systems are prepared for the future. In conclusion, addressing these additional considerations helps to provide a more comprehensive understanding of the working space requirements for electrical enclosures. By taking these factors into account and seeking professional guidance when needed, you can help to create a safe, reliable, and future-proof electrical system. Let's also consider the role of arc flash studies in determining the appropriate working space requirements for electrical enclosures. An arc flash study is a comprehensive analysis of the potential hazards associated with arc flash events, which are dangerous electrical explosions that can occur when a short circuit or other fault condition exists. The results of an arc flash study can be used to determine the appropriate level of personal protective equipment, or PPE, that is required for qualified personnel working on or around electrical equipment. The study can also help to identify potential hazards and recommend measures to mitigate the risk of arc flash events. In some cases, the results of an arc flash study may indicate that additional working space is required to provide adequate protection for qualified personnel. This is particularly true for equipment that is located in confined spaces or that has a high potential for arc flash events. Therefore, it's important to consider the results of an arc flash study when determining the appropriate working space requirements for electrical enclosures. In addition to arc flash studies, other types of safety assessments may also be helpful in evaluating the potential hazards associated with electrical equipment. These assessments may include hazard identification studies, risk assessments, and safety audits. By conducting these assessments, you can identify potential hazards and develop measures to mitigate the risks. It's also important to involve qualified personnel in the safety assessment process. These individuals have the knowledge and experience necessary to identify potential hazards and recommend appropriate safety measures. By involving qualified personnel, you can help to ensure that the safety assessment is thorough and accurate. Moreover, consider the use of technology to enhance electrical safety. For example, there are a variety of tools and equipment available that can help to reduce the risk of electrical accidents, such as non-contact voltage testers, insulated tools, and arc flash suits. By using these tools and equipment, you can help to create a safer work environment for qualified personnel. It's also important to provide ongoing training to qualified personnel on the proper use of these tools and equipment. This training should cover topics such as the limitations of the equipment, the proper procedures for using the equipment, and the potential hazards associated with the equipment. By providing ongoing training, you can help to ensure that qualified personnel are using the tools and equipment safely and effectively. In addition to technology, consider the use of administrative controls to enhance electrical safety. Administrative controls are policies and procedures that are designed to reduce the risk of electrical accidents. These controls may include lockout/tagout procedures, written safety plans, and regular safety meetings. By implementing administrative controls, you can help to create a culture of safety within your organization. It's also important to enforce these controls consistently. This means ensuring that all employees are aware of the controls and that they are following the controls properly. By enforcing the controls consistently, you can help to ensure that they are effective in reducing the risk of electrical accidents. In conclusion, addressing these additional considerations helps to provide a more comprehensive approach to ensuring electrical safety. By considering arc flash studies, safety assessments, technology, and administrative controls, you can help to create a safe and reliable electrical environment for your employees, customers, and the public.